Hello friends, welcome back to our channel The Quantum Quest. In this video, we are going to solve some more problems related to box product or scalar triple product. So first question is, determine lambda such that vector A is equal to I plus j plus k, vector B is equal to 2i minus 4k and vector C is equal to I plus lambda j plus 3k are coplanar. So we have to find the value of lambda and the given condition is that these three vectors are coplanar. If these three vectors are coplanar, then that means their box product will be 0. That is box A, B, C is equal to 0. Now box ABC means it is vector A dot vector B cross vector C, which is equal to determinant 1, 1, 1, 2, 0, minus 4, 1, lambda 3. Now when you expand this determinant, you will get 1 times 0 into 3 is 0 minus 4 lambda minus 1, 2 into 3 is 6 minus 4 plus 1, 2 lambda minus 0. So when you calculate this, you will get 4 lambda minus 6 plus 4 is 10 plus 2 lambda, which is equal to 6 lambda minus 10. Now this is our box product, 6 lambda minus 10. Now the 6 lambda minus 10 is equal to 0. So 6 lambda minus 10 is equal to 0. That means lambda is equal to 10 by 6, which is equal to 5 by 3. This is our answer. Our second question is, show that the 4 points minus 6i plus 3j plus 2k, 3i minus 2j plus 4k, 5i plus 7j plus 3k and minus 13i plus 17j minus k are coplanar. So in the question, 4 points are position vectors of 4 points are given. First we should find the points. Okay, let me name the points as A, B, C and D. Our first point A is minus 6, 3, 2. B is 3, minus 2, 4. C is 5, 7, 3 and D is minus 13, 17 and minus 1. Next, in our question we have to show these 4 points are coplanar. So to prove that, vector AB dot AC cross AD is equal to 0. This is the condition for coplanarity. Now vector AB is 3 minus 6, 9i. Minus 2 minus 3 is minus 5j. 4 minus 2 is 2k. This is vector AB. Now vector AC. Vector AC is 5 minus 6 is 11i. 7 minus 3 is 4j. 3 minus 2 is 1k. This is vector AC. Now vector AD. Minus 13 minus 6 is minus 7i and 17 minus 3 is 14j. Minus 1 minus 2 is minus 3k. Now we should find AB vector dot AC vector cross AD vector. AB vector dot AC vector cross AD vector is equal to determinant 9 minus 5 2 11 4 1 minus 7 14 minus 3. Now this is equal to 9 times 4 minus 3 is minus 12 minus 14 minus 5 11 to minus 3 is minus 33 minus 7 plus 2 into 11 into 14 is 154 minus 28. Now this is equal to 0. Hence we proved that vector AB dot AC cross AD is equal to 0. That means all the 4 points are coplanar. Our third question is, find the constant A such that the vectors 2i minus j plus k, I plus 2j minus 3k and 3i plus aj plus 5k are coplanar. So in the question it's given that these 3 vectors are coplanar. That means the box product is equal to 0. So when you equate it to 0, you will get the value of A. Okay. So let's first name these vectors. We will call this vector as vector B. Vector B is equal to 2i minus j plus k. Vector C is equal to I plus 2j minus 3k. And vector D is equal to 3i plus aj plus 5k. Now we will equate this to 0. Box BCD equals 0. This is equal to, box BCD is equal to determinant 2 minus 1 1 1 2 minus 3 3a 5. So when you expand this, you will get 2 times 5 into 2 is 10 minus 3a, which is plus 3a minus 1 times 5 minus 9 plus 1 times a minus 6. This is equal to 28 plus 7a. Now when you equate this 28 plus 7a to 0, you will get, this is 7a is equal to minus 28, a is equal to minus 4. This is the answer. Our next question is, prove that the 4 points 4i plus 5j plus k, minus 1 times j plus k, 3i plus 9j plus 4k, 4 times minus I plus j plus k are coplanar. So we have to, 4 points are given. First we have to name these 4 points and then we should prove whether they are coplanar or not. So in the question it's position vectors of these 4 points are given. So let's name the points. Point A is 4 5 1. Point B is 0 minus 1 minus 1, and point C is 3 9 4. Point D is minus 1, it is minus 4 4 4. Okay, now we should prove that whether these 4 points are coplanar. So if first we have to choose a reference point. Let's choose point A as the reference point. So when we write the equation, the condition for coplanarity, vector AB dot AC cross AD is equal to 0. So first we have to find vector AB. Vector AB is equal to 0 minus 4 is minus 4i, minus 1 minus 5 is minus 6j, minus 1 minus 1 is minus 2k, vector AB. Now vector AC is 3 minus 4 is minus 1 minus I, it is plus 9 minus 5 is 4j, 4 minus 1 is 3k. Now vector AD, minus 4 is minus 8i, 4 minus 5 is minus j, 4 minus 1 is plus 3k. Next we have to write vector AB dot AC cross AD equals determinant minus 4 minus 6 minus 2 minus 1 4 3 minus 8 minus 1 3. So we should expand this determinant. Minus 4 times 4 into 3 is 12, minus 3 minus 6, which is plus 6, times minus 3 minus 24 plus minus 2 1 minus 32. When you calculate this, you will get the answer as 0. Hence, we have proved that these four points are coplanar. Hence, proved. Our fifth question is, if the vectors vector A, vector B and vector C are coplanar, show that determinant vector A, vector B, vector C, vector A dot vector A, vector A dot vector B, vector A dot vector C, vector B dot vector A, vector B dot vector B, vector B dot vector C is equal to 0. So in the question it's given that these three vectors are coplanar. That means box A, B, C is equal to 0. That is, if box ABC is equal to 0, then it means box ABC the whole square is also equal to 0. Now box ABC the whole square is, this is an important formula, box ABC the whole square is determinant vector A dot vector A, vector A dot vector B, vector A dot vector C, vector B dot vector A, vector B dot vector B, vector B dot vector C, vector C dot vector A, vector C dot vector B, vector C dot vector C. Now if you look at these two determinants, we can see that these two rows are common in both the determinants, these two rows. So only difference is this row. So we can take from this row we can take vector C outside the determinant. So this becomes vector C dot determinant vector A dot vector A, vector A dot vector B, vector A dot vector C, vector B dot vector A, vector B dot vector B, vector B dot vector C, vector A, vector B and vector C. Now this we have already said that box ABC the whole square is 0. So this is equal to 0. So this implies this is equal to 0. Now vector C cannot be 0. So this determinant can be 0 but vector C cannot be 0. So we can write determinant vector A dot vector A, vector A dot vector B, vector A dot vector C, vector B dot vector A, vector B dot vector B, vector B dot vector C, vector A, vector B, vector C is equal to 0. C vector cannot be equal to 0. Okay. Now if we interchange the rows in this determinant, we will get the determinant given in our question. So determinant vector A, vector B, vector C, vector A dot vector A, vector A dot vector B, vector A dot vector C, vector B dot vector A, vector B dot vector B, vector B dot vector C is equal to 0. How this came? By interchanging the rows of this determinant. Interchanging rows. So that's all for today. Thank you.